Good evening and welcome to Africa's Vision Network. Africa's Vision Network features African cultural awareness, education, economic empowerment, religion, spirituality, and other issues focusing on the African world. I am Princess Ayo, your host for the show. Our program this evening will focus on motivating our children to excel in mathematics. And we have a very special guest. She is our own Breann Roberts, a friend of mine, and a native of Newark, New Jersey, who is usually working the camera, and she's sitting in a chair this time. But I happen to know she's very well read and very knowledgeable about education. So I already know she knows so much. You're going to be really educated by this woman today. She is a certified mathematics teacher for K through 12 in the state of New Jersey and North Carolina. And right now she teaches in Alexandria and Fairfax County, Virginia. Miss Roberts is a teacher with multiple skills. She writes lyrics, which I didn't know until just now, and songs, and is a seamstress. She is the proud mother of Breann Roberts Gregory, who is in her third year at Spelman College, and Kofi Alexander Roberts. Now, Breann was our director for a couple of years. I think she was 15 when she started.
Yeah.
Imagine, we're so proud of our young people that do their work here. But Breann was our director. Right now, she is on the Dean's List and in the National Honor Society. She has studied abroad in countries of Spain and the Dominican Republic. Right now, she is studying abroad in South Africa, this young lady, okay, at the University of KwaZulu-Natal in Pietermaritzburg, South Africa, for a semester. Now, Kofi, her younger brother, is an honor roll student and a saxophone player at Kenmore Middle School in Arlington, Virginia. Robin graduated from Georgetown University, and she went to Fayetteville State. And what state is that in?
North Carolina.
In North Carolina. Robin believes that one of the highest honors a mother can give her child is the best education possible. Robin and her children are part of the staff of Africa's Vision Network, as you know. Kofi serves, now this is the younger child now. The older sister was a director, and Kofi serves as our character generator and occasionally as a cameraman for the show. And you see, they're all part of the family. It's exciting. We do all things here, and we have all these talented people. As a teacher, Robin feels it is her responsibility to reach all students in order that they can reach their fullest potential. Welcome to the show.
Thank you for having me, Nadia.
It's so nice to have you sitting here with me instead of directing me and telling me what to do from behind the camera. But this is cool. Now we're going to talk about mathematics, and teaching. And for us girls, especially of our age, a little beyond 30, we were taught, as girls that math was hard for us and easy for boys. So we're looking at a woman who you chose mathematics as your career. And why did you do that? What happened? How did this happen?
Well, when I was in grade school and all, it's true that I was told that boys were better at math and, more apt, and it wasn't really the girls' profession. But I never listened to it because I liked math. I understood it. And I just didn't understand what people were saying or why they were making statements like that. It never made a difference to me. So I never pretended as if I didn't understand just because I was a female. That just didn't seem important.
Now, did you find other girls in the class were maybe liked it, but they pretended? Did you feel that was happening around you?
I don't remember. Probably so.
But as with all mathematicians, you were caught up in your own little figures. And you were like, I don't care about anybody else. I love it.
There were girls in my classes, but I can't say that they were usually the top performers.
Okay.
Maybe a few.
Okay. So you moved to Arlington. And why did you choose that? We see you've been all over.
Well, I had gone to school in the area, and I decided to come back. It's a nice metropolitan area. There are a lot of opportunities, basically, for my kids and for me. So I'm a city girl, and I wanted to live in another urban area that I would feel comfortable with.
Okay. Yes, I agree. It's good for raising children. And one thing I didn't tell the audience was that we're both from East Orange, New Jersey.
Yes, we
live there,
are.
so we have these, memories of what it was like growing up in New Jersey, around East Orange, in Newark. I went to church in Newark.
Oh, okay.
My mother's from Newark, so I know that area. So I know what you mean about moving to Arlington. It's just a different place in Virginia.
Yeah.
Now, in mathematics, only 4 countries, this is the Washington Post in 2007 said this, in mathematics, only 4 countries had average scores lower than the United States. Students in 23 countries had a higher average score, and those in 2 countries did about the same as Americans. The ranking of U.S. students in math and science is about the same as it was in 2003. Why do you think our students are lagging behind other countries in math?
Probably because of the way students in the U.S. are taught now.
Okay.
I've been teaching math about 20 years, maybe a little bit more. And when I was a student, we did not have calculators, for example, in the classroom. And I remember with the advent of calculators in the classroom, I saw students do something I hadn't seen before. When they were asked their times tables, they pull out a calculator. And they depended on the calculator being accurate and to do things that they could actually do themselves. So I think that the students in the United States still have the same abilities. They just aren't asked to do as much.
Is it that they're not taught how to learn it? Is that possible?
I think they're given kind of a misconception about what math is and what it does. For them, for example, this thing with the calculator, and I guess I just have an issue with those. Students feel like they're actually doing mathematics when they pull out a calculator and they graph, functions or, do times tables, etc. I don't really feel that way. They are removing themselves from the thinking process in mathematics.
And the calculator is actually doing the math for them.
The calculator's doing the math.
It's like thinking for them, is it?
Yes, it's thinking, but it's not actually thinking for them. They may think it is, but the thinking is not going on. So they're not making all these connections that I was forced to make, and I didn't have a problem with it, but I had to make those type of connections because I wanted to learn how to do the calculations. I wanted to have some brevity in it. I didn't want to take an hour and a half to do something that if I understood the math, I could do in a minute. So they don't have to do that.
And, thinking about other countries, there was an article in the news last March about British twins in high school at age 9. They happened to be of Nigerian background. Their names was Peter and Paul Imafadon, who had aced the University of Cambridge advanced math exam, and they were the youngest kids ever. And I can imagine how this is possible, And I do remember coming to America when I was 11 to go to school and being put in a higher grade because my math was so advanced. And yet I had to go back and, unfortunately, Nigeria was like they didn't emphasize reading, but they emphasized math. So I had to go back to do my reading to catch up. But not too far back because my mother was always, the bookworm in helping us. But math, I was so far advanced, I said, we can't put her where she belongs. Because the children would be too much older than her. She would feel awkward in that class. So I had to go only for math. And then come back to my regular age group. So I do understand how this could happen with these young kids in Nigeria, or who are from Nigeria originally. I
can say that it doesn't usually happen, but I'm not shocked because we don't really know our potential. We're told that we only use a really small fraction of our brain, so these students are obviously very focused. And I don't doubt, no, I know actually that there are many students that could do that were they that focused, were they that supported, because they are actually that bright.
Now, what approaches do you use as a teacher when you have a slow learner in the class? I
try to approach the teaching from different points of view. One of the first things I found out when I started teaching was that everyone didn't see it the way I did. And I was so shocked. I was really surprised. And so it required me, if I explained something one way, and the student doesn't get it, it's not the student's fault, it's my fault. I need to find another way. So I come from another angle. Maybe I'll do something visual, maybe something, you know, that has to do with hearing. It depends on, it's something personal about the student that will make them buy into what I'm trying to show them how to do. And I constantly remind them that they actually can do it, and it's not really that difficult. I don't happen to believe in elitism in mathematics like, unfortunately, many math teachers do believe.
Right. That certain people are good at math and some people are not?
Yeah, I've never subscribed to that. I don't think I would actually fit into the group that was supposed to understand. You know, I mean, after all, I was born in Newark, New Jersey. I'm an African-American female. I'm not really supposed to be good at math, as they say, and I am. So I can't really subscribe to that type of stereotype. So I don't really pass that along to students. And even if they tell me, and you'd be surprised, sometimes students tell me, well, you know, I'm not really that bright. And I'm like, well, no, I don't know anything like that, but I do know that you can understand this, and I'm not asking you to step into a physics class, but you could, you know, with the right training, I'm sure you could. But I'm sure there's a way that we can find that, you know, you're going to understand this. And I never think of it as a student just not capable. That's not true.
And probably when they have some success and they realize that they can actually do it, then they're like, she was right. I am smart enough. So, I mean, you find that happen. What kind of tools do you use then to motivate them to achieve?
You know, maybe art. A lot of students, they love art, and I try to, like sometimes when I design tests, which I do enjoy doing.
Well.
I put, I do, I really like it, designing tests, but I put artwork in it and I put humor into it. I write kids into word problems, you know. I have them imagined as a business owner or some type of scientist or whatever. So when they read the test or the assignment, they get interested, they start laughing, you know, because they're actually in it. And for many students, this is a new experience because they're not actually the center of many of the experiences that go on in the classroom.
So you're using storytelling.
Yes, definitely.
Which is our first language.
Yes,
and makes you remember.
I never thought of it that way, but it is true.
It,
and I have to say that I come from a long line of storytellers. My mom actually writes and stars in many of her plays and puts them on, and my father, we just a long line of storytellers.
I can just imagine how that must work. Now, parents that have children who are having problems, what can the parent do to support their child in becoming a good math student?
I think some of the things that we do at home, you know, there's a lot of math in everything we do. At schools now, they send home packets, you know, where they ask the parent to help out. And I hate to admit this, I never do those. I just can't stand them. I feel like I'm not the teacher in the classroom, and I'm not going to do a lesson plan in my own house. But what I do is, for example, when I was teaching my children about fractions, we like boiled eggs in our house sometimes, so I would cut the eggs in half or cut them in fourths, and, you know, I'd say, well, how many fourths do you want? You know, how many eggs do you want? And then I would, you know, like maybe we have 2 eggs or something, so we've got 8 fourths, and I would try to trick my kids about what amount they were receiving, but because they knew what they wanted, they quickly understood, you know, what the difference between the halves and the fourths were, and how you could compare the two, and the equivalency. Or I had glasses that have ounces on them, and I said, well, how much juice do you want? You know, 2 or 3 ounces. So they begin to have these measurements, something that they use in everyday life. And I think that's one of the problems. That's another one of the problems with math. We don't do things anymore that involve everyday life, and it makes math something that's tangible for kids. You know, for example, if kids cook, they can use measuring cups, etc. That may not happen as frequently, but at least you're doing that. But, you know, like I say, when I ask them, well, how much juice do you want, you know, and they have to be able to tell me the difference between 2 and 3 ounces, and then they internalize that difference.
Right.
I use, I sew. So I had a nice project with students where they would use polygons, which is a many-sided figure.
Yes.
They would cut from old jeans. They would recycle, cut bags out of it, and I would bring in my sewing machine and actually let them sew.
Wow. The math teacher.
Yes.
Wow.
And there's measurement in that. There's congruency, which means that the front and the back fit together evenly.
Right.
So you want it to look like some nice product. As we would say, you don't want it to look mammy-made. You know? So,
which working like that eliminates the calculator.
Oh yeah,
Because they're actually seeing the math happen in front of them.
And they use rulers. Kids do not use rulers, you know. Now they're getting back into having measurements in class, but when I grew up, we used rulers all the time, you know. So I found that kids in high school and middle school, they didn't know how to measure for real, because they actually don't. A lot of things are duplicated on worksheets and all that, so a lot of math had, you know, was being done that way.
Right.
And that just removes the reality from it. Again, it's not abstraction, it's just like removed. It doesn't mean anything. It's kind of meaningless. So I try to bring meaningful situations to the math class so that the students will become engaged.
How, now that you're talking about sewing and cooking, I wonder, you know, this could elevate the thoughts children have that I don't need math. How am I going to use math later? So how does, tell us, you know, for the parents that are listening who are maybe thought that when they were young, how does math support other studies and everyday life?
Oh, you know, math is a basis for so many things. I actually went back to school, and I had already been a teacher when I did, and I was in a science program. And so I noticed that the students, they would do everything in the class, like say biology, for example. But when it came to the part that had mathematical applications, they backed off from that. And they actually would try to go through the course without doing the math because they didn't feel comfortable with it. But if you work as a scientist, you quantify everything you do. I mean, you have to show that these experiments actually work, so you have to replicate the experiment again. Or if you work as not a statistician, of course that would be math, but a social worker, you have to take, we take a lot of statistics. Right. We, you know, we average them, we show trends, etc. And I don't mean as a statistician, I mean as a school teacher, you know. When I grade papers, I have to put my curve on, you know, how many students got an A, how many got a B. Then I go back and look at what type of problems we gave children the most trouble.
Right.
So we use a lot of math to understand the data that's happening in our everyday lives. So it has a lot of applications. I was talking with a student recently, and we were talking about the interest rate, which is kind of abstract for a child that doesn't work and doesn't really have an income, etc. But then I was asking them about if you bought something on sale, but you used a credit card, and you had to pay the finance charge, and we calculated the finance charge, and so they found out that even though the thing was on sale, it wasn't really on sale once they used that credit card. So then the student told me, well, I'm not going to use credit cards.
That's a wonderful lesson by itself.
It is, and it's the lesson that we really should be teaching in the math class.
Right.
Of all classes, finance, the credit problems that people have, you should be able to sit down and calculate what that finance charge really means.
Yes.
There's just no excuse
and I think,
for it.
Now, my grandson is 7, but I've seen some algebraic notions coming home in his math.
Yeah.
So, I mean,
Yeah,
a second grader could do algebra?
Certainly.
To be able to show how it relates to life?
They can.
Which blows my mind, because I didn't do algebra to 8th grade. You know?
Well, they really can. I'm even told there's a book out that has, calculus for elementary age children.
Whoa.
Not that they're going to really be doing the full course.
Right.
But the concept, and sometimes when I go in class, and we finish most of the work, because I do a lot of substitute teaching now, I say, well, you want to do a little calculus. The kids are like, yeah, they don't know what it is, And I say, okay. And I show them how to do a derivative, which is a very simple concept, when you first start.
Yes.
And they're like, I ask them to look for the pattern. I do it, and then I ask them to look for the pattern. They figure it out. Well, that's the way it's done. Math has a lot of patterns in it. So, yeah, they can do it. It's just, are you going to teach it? I'm always amazed. My son is in middle school now, and they have all these I don't say constraints about who can take algebra and who can, and if you're algebra ready. I mean, the number of tests and gauges they have to decide if you're even ready is almost mind-boggling, and it's ridiculous. It's algebra.
And that, I was thinking about this question, that how can educators determine a child's threshold?
Well, in my opinion, and this is just my opinion, they cannot. And any educator that figures they can do that should probably remove themselves from the classroom and find another profession, because it's not for us to decide what a child's potential is. The child decides that, by how hard they work. And I'm not saying that some kids don't have, legitimate learning disabilities, but there are ways to overcome almost anything.
Yes, yes.
I've been in I've seen some wonderful things as a substitute teacher. The most touching thing, I think, is I was at a school where the special ed children were put in a stage play, and it was a very nice, it was the Christmas Carol.
Right.
Very nice production, full costume and everything, and every child had a role. There was a special ed child that was the lead, the Scrooge. He was excellent. People were like, he had a voice that you just couldn't forget.
Yes.
But then we had children that were really challenged, that the best they could do was put a costume on the child and then have someone lead the child across the stage. But that was done.
Right.
So the child was in the play.
Right.
So I'm saying, look, if you can do this and put on a really nice production of the Christmas Carol,
right,
with children that actually do have, legitimate needs,
right,
or challenges,
surely,
how is it you can't teach algebra to a child that has all their faculties?
Absolutely. Can you believe we have like a minute? Been yakking away, but this was truly interesting. This really was. We got a lot in here, Robin, in our short space of time.
Okay.
And I really appreciate having you. Any last words of wisdom for us?
Yes. Put your child in the best math class you find in that school and do whatever you need to do to make sure they can get through it, because it will benefit them.
And knowing you, keep fighting right along with them.
Oh, definitely.
That's what I've learned from Robin. Keep fighting for those kids and keep going to the school and fighting for your child to have the best.
Thank you again.
Thank you so much for coming on this side of the camera.
I've enjoyed it.
I know. I've enjoyed it also. And audience, we so appreciate you stopping by to watch us. And we believe you'll be back next time when we have a wonderful episode of Africa's Vision Network. We want to close our program today by dedicating this program to one of our renowned and beloved African American scholars and mathematicians, Dr. Abdulalim Abdullah Shabazz. Dr. Shabazz was born Lonnie Cross and grew up in a small town in Bessemer, Alabama, about 70% African American, in what one can describe as an African village in a loving and nurturing environment. He received the Bachelor of Arts degree with honors in mathematics and chemistry from Lincoln University, Pennsylvania, 1949, within 3 years. Salutatorian of his class, the master's degree in mathematics from the Massachusetts Institute of Technology, MIT, in 1951, and the PhD in mathematics from Cornell University in 1955. He reads fluent French and German and speaks French, reads and writes and speaks Arabic. Dr. Shabazz holds a special significance for the African American community because he is directly responsible for awarding many of the master's degrees in mathematics. During Dr. Shabazz's tenure at Clark Atlanta University, his department was responsible for awarding 109 master's degrees in mathematics between 1958 and 1963. About 40% of his graduating students went on to receive PhDs in mathematics or mathematics education. Dr. Shabazz stated that the PhDs began rolling in 1963, and they are still being awarded, with the last that I know of being awarded to Julius Davis, a student of mine, when he was at Lincoln University of Pennsylvania, in mathematics education by Morgan State University, May 2010. This giant of a man, Dr. Shabazz, has held positions during his life that include industry as well as academia. His appointments have included that of research mathematician at the Cornell Aeronautical Laboratory in Buffalo, New York, and at the Metals Research Laboratory of the Electro-Metallurgical Company in Niagara Falls, New York. He has served on the teaching faculty of several universities, including Cornell University, Tuskegee University, Alabama State University, Atlanta University, Mohammed Islam in the District of Columbia and in Chicago, Illinois, Al-Qura University in Makkah, Saudi Arabia, Clark Atlanta University, Morehouse College, and Lincoln University of Pennsylvania. He was an imam for many years. Today, Dr. Shabazz continues his love and dedication in the field of mathematics. He is the endowed chair in mathematics and professor of mathematics at Grambling State University in Grambling, Louisiana, in the Department of Mathematics and Computer Science. Throughout his illustrious career, he has received numerous awards, to include the Presidential Award by President Clinton in recognition of his excellence in mentoring underrepresented students and encouraging their significant achievement in science, mathematics, and engineering. He has traveled widely as a lecturer and consultant and authored over 100 publications on Islam, mathematics, and mathematics education, and on the history and philosophy of mathematics, including 3 books. He holds memberships in many organizations. He is internationally recognized for his philosophy on a proper mathematics education for all people. We honor this giant, and we know that his works and deeds will be recorded in the annals of world history.